Welcome to the sport of rowing. Today I'll be talking about the physics of rowing and how they incorporate the stroke, the power, the resistance, and also the balance. As you see here, I'm rowing on a pennant, which is a single scull boat, and I'm using two C2 oars, which is also known as sculling. The one which you row with one is called sweeping. As you see here, I'm using my head to turn around and look at where I'm at. In order to change directions, I would need to pull on my right oar in order to move left and my left to move right. Because I'm doing this because there's no steering mechanisms in singles, but in bigger boats there are. The stroke is the most important thing of rowing. Having good technique can make you a very good rower, and just applying more pressure to the stroke can make you move very fast.
To finish?
The first thing you do when you come up to the finish, which is when you finish right there at the stroke, is you put your arms away first, then your back, and then your legs. You move up the slide very slowly in order to minimize the amount of momentum that is moving in the opposite direction of where you're going. As you know, the boat is moving forward, and you need to come back up to the slide in order to catch again. If you move very fast, there's a thing called rushing, which if you're in a bigger boat can mess up the boat. But on a single, if you could see, when I move up the slide very quickly, the boat goes in the opposite direction, and that's not good. That ruins your time. So, right when you come up to the catch, you feather the oars so you can have a very good and quick catch in order to reduce friction with the oars in the water. And then you catch with your legs, your back, and then your arms. The legs are the most powerful part of your body, and then the back is second, and first is the arms. This also, if you move quickly at the finish, right now, then you have very good balance. And balance is very key, which I'll explain later on. The stroke also uses the 3 Newton laws of physics in order to determine its propulsion. Propulsion is determined by when there's an action, there's always an opposite reaction. When the oars push away the water, the boat moves in the opposite way of where the oars are pushing. Also, that momentum or motion will be at a constant speed when there's no external forces used. This is eminent when I'm not rowing, the boat is moving, except for when the water causes friction, which slows it down. The start is very important in a race. It can either make you win or lose a race, and this is imminent in kinetic force. The way a boat deals with kinetic force is in the start. Usually the first stroke is half or a quarter slide, and this is a quick stroke which starts the boat off from static to kinetic force. And we know this because static, it's harder to move the boat from static to kinetic force. So once the boat is in kinetic force, the boat moves quicker through the water, and then you can go to full stroke, which gives off the most power. Balance is important during races because it can either stop your boat, or you can flip or catch a crab. Balance is used importantly with center of mass. As you can see, when I'm turning, the boat is moving side to side because the balance and the center of mass is changing from one side to the other because weight is distributing to one side and to the other. In order to combat that, you have to put both oars on the water and push down in order to stabilize the boat. This can be also done with arms away quickly at the finish in order to move the weight to the center of the boat and create a center of mass and use the buoyancy against the gravity. If you do this, both oars will be able to get out of the water and stay out of the water when they are flattened. And by doing this, you can have a quicker catch and move quicker. 2 important frictions in rowing. The first one is the water, which connects with the hull and slows it down, and is one of the main effects of the Newton's second law, which states that momentum will be constant, or there will be a stop until some outside force or external force causes it to move. This is true because if there wasn't any external force stopping it, like the water, then I would be moving at a constant momentum or acceleration or velocity. So because of that, that's what makes the boat slow down, and that's why I need to move slowly up the slide in order to make that less and let the friction not affect the boat as much. Hopefully, you know more about rowing and the physics that surround it. You now know about the stroke, the resistance, the propulsion, and the friction. And now, you know more about rowing and everything that surrounds it, and now you know more about the sport. Thank you.